Now we come towards the different types of modulation techniques when the carrier waves are sinusoidal continuous waves. So different types of modulation we have to discuss and the techniques when the carrier waves are sinusoidal, that is in the form of a sine graph and continuous waves. Three types of modulation of continuous carrier waves are there. First is sinusoidal carrier wave can be represented by a general equation, that is Ct equal to AC cos omega Ct plus phi naught. Phi naught is the initial phase, and initial phase means initial position and direction of the wave, and omega c is the angular frequency of the carrier wave. T is the instant of time when the wave is located. AC stands for the amplitude of the carrier wave, and Ct is the signal strength, that is voltage or current, and it is in the form of continuous sinusoidal wave. So we proceed like this. Ct is the signal strength, voltage or current, AC is the amplitude, omega c 2 pi fc, or it is 2 pi by lambda is the angular frequency, and phi naught is the initial phase of the carrier wave. The quantity phi is equal to omega c t plus phi naught, where phi is the phase means position and direction at instant of time t. That is called the phase of the wave. The above equation shows that carrier wave can be modulated by controlling any of the three parameters. So we have to control the parameters like AC, that is amplitude of the carrier frequency, omega c, angular frequency of the carrier wave, and phi naught, that is the initial phase. The phase can be given by function 2 pi x over lambda, where x is the path difference. So phi naught by the message or the information signal. This results in the following three types of modulation. Number one is the amplitude modulation. Number two is the frequency modulation. And then it is original frequency of the carrier signal is called resting frequency. So amplitude modulation is the process in which the amplitude of the high frequency carrier wave changes in accordance with the instantaneous value of the modulating signal. Then comes the frequency modulation. So in this process, it is the process of changing the frequency of the carrier voltage in accordance with the instantaneous value of the modulating voltage. The instantaneous value is given as V is equal to V naught sine omega t. The original frequency of the carrier signal is called resting frequency or the center frequency, that is Fc. The amount by which the frequency of the carrier wave changes or shifts above or below the resting frequency is called frequency deviation, and small frequency deviation is directly proportional to mt. Now we come towards the phase modulation, like position and direction modulation. It is the process of varying the phase angle of the carrier voltage in accordance with the instantaneous value of the modulating voltage. Now we have to draw a diagram. Our question is related to that we have to draw modulated wave for the phase and the frequency modulation of the sine wave carrier by sine wave signal, and we have to distinguish between the two. So we have a figure here, that is figure A. We have to go through the next concept regarding the figure. Figure A will show a carrier wave, and figure B will show modulating sine wave signal. Figure D will show frequency modulated wave, and figure E will show the phase modulated wave. So these all figures are shown here, and the C figure is basically for the amplitude modulation of CMT. And similarly, the another figure D is for the frequency modulation, as already I have expressed, and the third one, that is E, that is for the phase angle modulation. So if we compare figure E with figure B, then we find that the frequency of the phase modulated wave changes in accordance with the phase of modulating signal. We can see the figure from that. So here, whatever statement is mentioned, that can be conveyed from this figure. So we can look at the figure. Frequency is maximum when the phase angle is 0. It decreases when the phase angle increases and becomes minimum when the phase angle is pi, that is 180 degrees. Frequency again increases and becomes maximum when the phase angle is 2 pi, that is 360 degrees, because for 360 degrees wave has more energy. Now comparing the figure D with B, we find that the frequency of the frequency modulated wave varies proportionally with the amplitude of the modulating signal.